Good day to Dr. Hamidin. My name is Chloe Kaji and my matching number is AP190230. And we are Group 3 in giving presentation on the bridge modeling of our group project. This is our members of the group, which is Yao Jiaxing, Dui Mendong, Dan Shiqi, and me, Chloe Kaji. So I'll be giving the presentation on the introduction part. What is structural analysis? So in this link between a structural component can we understand the relationship between a structural member's expected external load and the structure's relevant developed internal stresses and determine to occur within the member when in service. As for what is the meaning of bridge? Bridge is a structure built to allow people or vehicles to cross over a river or a valley. So in designing the bridge structure, it must be appropriate to withstand load, internal load and external load that which will be applied so that the bridge can be used safely by the user. As there are several prototypes that each have particular purposes and are applicable to various circumstances where it reflects in timing, simplification of design, and material saving. On to the next point will be the objective. So this project is aimed to let students learn on the application of software such as the AutoCAD and LearnPro. Next will be encourage students to apply their knowledge on structural mechanics and solve practical problems. And as for last, it will be fostering effective communications between group members during discussion in completing their task. So this is the structural modeling of the project, which based on the regular, the overall length of the model is 10,000 millimeters, same as 10 meter. And the design is clear span between edges of supporting abutment must be 8,000 millimeters. The bridge width is 2,000 millimeters, and the maximum overall height is 3,000 millimeters. And next, in the contact-based area at each end of the bridge are 2,000 times 2,000 millimeters. So the bridge is applied uniform distributed load on bridge is 2,000 kg, same as 2 tons for overall length of the bridge. Onto the material applied to the bridges is used as steel. It is increased stability of the member. And the size of the I-beam for all member bridges is universal columns, which is at the dimension of 305 times 305 times 283 millimeters. And this will be the figure of our dimension modeling, as this is the shown of the front view of our bridge. And this will be our dimension of the bridge. And that's all from my part. Thank you.
Everyone, my name is Hussein. So today I want to show the model bridge that use the lip floor. So first we need to set the point. The height is 3 amps. So let's create the first for those point. So next we put the spot, the roller and the lip. Okay, next is the second bending moment in our point. Okay, we set O. So we show the red point that we create the point. So we get out the point. So we add the dot. Set the view. So we add the ID here. So this is our final info domain. So when you start to explain the info design models, in the first we can see is our design for the model of the bridge. In this diagram we can see in the lot is the 90.61 lot contains for the 2000 kg for the lots. So next is the moment diagram. Next is the shear force diagram. Next is the arc force diagram. The direction diagrams. And the final is the reflection diagrams. So final we find in the reflections, for the info and the bridge is the 0.0053 kS. Next is the tension and the correlation force in the internal force members. This is our find for the info results. So final in the AutoCAD drawings is the 4 views, top views, is the 4 views, is the 3D structures views. So thank you for watching.
Hello, my name is Tumono, metric number AP190262. I will continue the presentation for manual calculation. So there are 5 steps to do it. 1. Statical analysis, find reaction force, find point for every joint, find internal forces for every member, and last then compare internal force with linear calculation. So first is static analysis. We found that there are 3 reactions for one pin support and another roller support. So the total is 3 reactions. Assume that the truss is stable. Next, there are 29 members and 16 joints. So we can do the static analysis for plate for the truss. Formula is 2 equal to m 2j minus 3. So formula the calculation is the same number. So we assume that the truss is statically determined for internal and external force. Next is find the reaction force. Before that, we need to do conversion for 2000 kilogram. So we assume that 1 kilogram is 99.8 Newton. So we can do the calculation for two types. So because the reaction is two unknown forces, we can do them for the moment equilibrium first. So moment of P equal to 0. Next is 2000 kilogram times 9.8 Newton and divided by 1000 Newton for the conversion to kilonewton and times 10 because the 2000 kilogram is distributed load. So we use to find the middle point of the load. And then for the times 4 is the for the member of the distance. So from P to here, there is 4 meters. So we can find. So for the next is equals to 8hy. So for the hy is another 4 meter, which is 8 meter. So for the calculation, we can know that the hy is equal to 9.8 kilonewton. So we bring it to here to find the reaction of py. So for the reaction forces of py is 98 kilonewton, which is same. For the next step is find the load, point load for every joint. Because this is a distribution load, we can assume that every point of every joint has a similar load, which is 19.8 kilonewton for every joint for the bottom. So except the leftiest and the rightest, which is 9.8 kilonewton. So we can show the calculation here. Next step is find the internal forces for every member. So we can find out that we assume that every member has a tension forces. If the overall forces of the member is negative, we will convert it to the compression forces. So we will do the trigonometry calculation, which is this. So we'll do the calculation like this for joint A, joint P, joint B, joint A, joint P, and joint B. And then for next is joint O, joint N, joint C, joint N, and joint L. So for the calculation for all of these are already half of the way. Because of this is almost a symmetry like a mirror for left and right. We can do the symmetry summary like this. So this is the overall internal forces for every member. So as we can do that, the arrow for the outside is tension, arrow point inside of the member for every member is compression, and some of the arrows are double arrows. We assume that there's external forces or reaction forces. Finally, we compare with the Limpro calculation. So for the overall calculation, we found that the Limpro calculation and the manual calculation are almost similar to them. That's all from me. Thank you.
Hi, Dr. Hamidun. My name is Tan Suchi, number metric LP190249. Now, it's my turn to start the presentation of the part of recommendation and conclusion. Recommendation. The first recommendation is columns and beam. Columns and beam are important structure to support the bridge. The beams and columns will use the ultra-high performance fiber reinforced concrete. This is because UHPFRC structure have extremely low permeability, which largely prevents the ingress to detrimental. Next, UGPFRC also can withstand the high compressive strength height, tensile strength higher than 10 MP, and softening behavior. Besides, use the T-shaped columns are improving the height strength and good stability performance. For the example, compare the L shape. The T shape is more the high axis can improve the flexibility to support the lock. The second one, increase thickness of member in terms of its longevity. Thickness of the bridge will improve the durability and improve span life. The third one, use the CFRP retrofitting. The carbon fiber material is light quality, avoid corrosion, high tensile strength, and support the high tensile. For the example, strengthening principle of carbon fiber cloth and key points for reinforcement design of CFRP. CFRP will improve supporting ability of the beam bridge. In the conclusion, this project helps the student to improve to more the understanding the process of analysis and create the bridge. By understanding the concept, the students are gain how to determine the stable and not stable. In addition, they improve the key of calculation the internal force and other force in use the knowledge for cost structural analysis. So, students will use the skill of Limpro and AutoCAD when the applying job. That's all for our group project. Thank you.